In this video, we are going to look at multiplying and dividing rational expressions. As you work through these problems, try to pause the video often and work ahead of me a little bit, and then play the video and check your work and hopefully clear up any confusion. The first thing when you are looking at a multiplying and dividing rational expressions, is to realize what the operation is. So a common mistake is just like treating this like division, or more so treating division like multiplication. So notice that we are multiplying. When you multiply fractions, you just multiply straight across. This fancy word rational expression is just referring to the fact that there are variables in the denominator creating a fraction with variables. Okay, so we can multiply straight across. You can treat this as one equal sign or one fraction bar, really. If you want to just think of it as like going all the way across, that's fine, and then multiplying these things. So you can start reducing right away, or you can multiply and then reduce. I'm going to reduce kind of just right away. Before we do that, though, let's look at what cannot happen. So remember, when you are dividing, you can't have a 0 on bottom. So if I were to plug in 0 for x right here, it would create 0. So I want to say somewhere, and we're going to just put it down here, x cannot equal 0. And then also y is on bottom. And if y is equal to 0 in either of these spots, everything becomes 0. So y cannot equal 0. And these are called domain restrictions. Okay, so now if I just start dividing, so 8 divided by 2 is 4. And then actually, maybe it'd be better. Yeah, let's go ahead and do that. So 8 divided by 2 is 4. So we'll reduce that. Let's rewrite it over here. So 4 here with these x's. I'm just going to reduce this one here. So x and x cubed, that becomes x squared on top. And then with these y's, let's make it y squared minus y, or 1 rather. 2 minus 1 would be y on bottom. And then let's see if anything reduces over here. We have 7. And then x to the 4th, let's not touch that yet, although you could. And then 4, I see that reduces, so you might be able to do that in one step. We're going to keep it as 2. And then y squared and y to the 1st. So 2 minus 1 is 1. And that big number wins out, so y stays on bottom. Okay, so we've reduced a little bit here, but not completely. Let's go ahead and we might see these 4s will cancel or divide to 1. So let's make that happen. And then let's use our exponent rules. So on top we have 7, and then x squared and x to the 4th. Remember, you add when you multiply, so that's x to the 6th. And then y times y is y squared, because 1 plus 1 equals 2. And so there is your final answer. Everything is reduced. Okay, if we do not have, or if we have something that looks like this, the first thing you want to do is factor. So we're going to factor everything. And so go ahead and pause the video and try to factor. I think everything factors here. So go ahead and try that. I remember to look for a GCF, so I can take an x out here and make that x minus 1. On bottom, these have a 3x in common, so I can take a 3x and make it x minus 3. Over here, because the number in front of x squared is 1, we can take the shortcut method. So I need two numbers that multiply to 9 and add to negative 6, and they are negative 3 and negative 3. You might recognize that as a perfect squared trinomial and make it x minus 3 squared, which is fine too. And then this guy is going to be a little more complicated to factor. So let's do that off to the side down here. So two numbers that multiply to negative 6 and add to 1. And those numbers are 3 and negative 2. And then I'll rewrite the original problem here. There's a couple different ways to do it from here, but one way is to rewrite the middle term. So instead of x, we're going to use our numbers we found, 3x and then minus 2x. And then factor by grouping. So you can take a x out of the first one and make it 2x plus 3. And then a -1. The reason I know to take a -1 out is because I want these parentheses to look the same. And if I take a -1 out, they do look the same. And then that leaves me with 2x plus 3 for my new greatest common factor. That's the parenthesis that repeats. And then x minus 1 is what's left. If you don't understand factoring very well, that was pretty quick. So pause the video, think about that, look at the steps, maybe go back and watch that again. But you're going to factor a ton when you multiply and divide rational expressions, at least typically. Okay, the other thing with these, especially if you're working from a textbook or your math teacher's giving you problems, is usually they work out where things cancel. So, or divide to 1, I should say, cancel. If they don't, you might check. It's not like they have to, right? But typically, like as a math teacher, we write problems where you can do things. So if you got down to here and nothing like crossed out, you might think, well, maybe I did something wrong. It's kind of like when you first learned to solve equations. If you got a decimal, you thought stuff was wrong. Okay, before we start canceling, though, we want to state domain restrictions. So that's just where the bottom is equal to 0. Oops, almost spelled domain twice there. That's an R. So you look at the bottom of the fraction and just set each factor equal to 0. And we'll just put this down here. Say, well, x, if I had 3x equal to 0, then x can't be 0. X minus 3 is equal to 0, then x can't be 3, so you add 3 to both sides. This one's a little trickier. You have to subtract 3 and divide by 2, so that's minus 3 divided by 2, and this one gives us 1. So x can't be any of those things because it makes the original problem not make sense because you have to divide by 0. Okay, then you can just cancel, treat this as one fraction, and these x minus 1s are gone, they divide. X minus 3 is gone with just one of them, though. And then this x and this x divide out, and so you were left with x minus 3 over 3, don't forget that 3, times 2x plus 3. If you want to distribute that 3, you can, or you can leave it in the factored form. It's fine either way. Oops, I forgot to write that last step. So step 3 would just be divide or cancel. And then multiply straight across. Okay, with division. Division is going to be almost the same as multiplication, with the exception of a couple things. And I'm just going to write this up here. I maybe use a different color, but we're going to say rewrite the first and then flip and multiply the second. When you learn to multiply fractions, there's a lot of shortcuts people use. Sometimes you're got to like kind of cross multiply or multiply diagonally when you divide fractions. Sometimes you flip you're taught to multiply by the reciprocal. That's the right way to do it, but you only flip the second one and you kind of show your work funny. These you have to show your work in a way that is this, where you have to rewrite the first. So let's just rewrite the first and then flip the fraction. When you flip the fraction, you make it multiplication. So by doing this first, you'll eliminate a lot of common mistakes that I see. Okay, and then it's a multiplication problem. So we can just follow the same steps. Go ahead and pause the video and list or factor everything and see what you can get to cancel. Okay, so let's go ahead and factor. I'll put it down here. So we have x minus 2. This would be x minus 2 and x minus 3, because two numbers that multiply to positive 2 and add to negative 3 are negative, 1. Well, where did I get my? This is supposed to be 1. So I got negative 2 and negative 1, multiply to 2 and add to negative 3. And then I can take out a 2 here, leave me with x minus 2. Now, we do need to still state restrictions. Our restrictions are a little different here because we have 2 places we need to look, or 3, I guess. We have all the bottoms of the fractions up here. And then when we flip it, we have all the bottom again. So let's just look at this one here. So x is 2. And then this used to be on bottom, so x can't be 2, x can't be 1. And then this would mean x can't be 2 again, but we already have that. So x can't be 2 and 1. So you have to look at the bottom of this fraction, and because you're dividing the top of this fraction, which is now the bottom. So there's 3 places to look. Probably worth rewatching that and making sure you can make sense of it, or pause it and think about it for a bit. And then just reduce. So we have an x minus 2. I'm going to cross those out, and it looks like that's about it. Not much cancels here. Oh, wait, hold on. I factored that wrong. Sorry. This is supposed to be x minus 1. Take out the 2. Okay, so if that's a 1, then this cancels here with this, and then that x minus 2. And so that is x over 2. Okay, so once again, like with that mistake, if things don't cancel out a lot or quite a bit, you might have done something wrong. So I was only going to have one factor cancel. So I looked again and I thought, oh, well, maybe I did something incorrect. And I took out the 2, but I wrote 1 instead of, I wrote 2 instead of 1. Okay, and then on the last one, the first thing I like to do is just rewrite the first fraction and note that it is division. So as soon as you divide, you see the division symbol, you think I'm going to rewrite the first one and then flip the second one. It does take a little bit of extra time. It's showing a step, but it will save you time in the long run. Okay, then factor everything and see if you can reduce. This one, we'll do this one down below here, because the 2 is in front of x squared, so that's a little bit more difficult. So 2 numbers that multiply to 2 and add 3, and those numbers are 1 and 3. And so we rewrite, 1 and 2. I keep getting numbers confused in this video. I apologize. So it's 1x plus 2x plus 1, and then take out an x, because that's the greatest common factor. And you're left with 2x plus 1. Take out a positive 1 because we just want it to look the same. And then that's 2x plus 1 times x plus 1. And so this is 2x plus 1 times x plus 1. Down here you can take out a 12. And then this is a difference of 2 squares. That's x plus 1 times x minus 1. Okay, now you can state some restrictions. Let's just put it down here. So here x can't be 1. Here x can't be 0. And here x can't be negative 1. And this one's 1, which we already have. In a perfect world, these would be in order from smallest to biggest, but if you just want to list them as you go, that's fine too. And then let's see what reduces. So my x minus 1, does not reduce. Does not reduce. Whoops. I'll cancel that out. X plus 1 here, X plus 1 here. And then 12 goes into, or 6 goes into 12 2 times. So that gives me X times 2X plus 1. And then on bottom, 2 times an X minus 1 and X minus 1. So that's X minus 1 squared. And that is fully reduced. One thing to be careful of before we end the video is you can only cancel after factoring. That's because when you cancel, and it's really kind of a sin to say cancel in the math world, but it's how we think, so I use it. So when you cancel things out, you're actually dividing. And so you can only divide if you're multiplying all the way. So when you factor, you turn all this addition here into multiplication, which is why you can cancel like that or divide. So be sure you're only canceling after factoring. If you were to try to cancel like this x squared and this x, that does not work. It's not allowed because you're adding these terms and subtracting. But here, these parentheses indicate that you're multiplying the things. So canceling is allowed. Okay, good luck and reach out if you have any questions.